Hi guys, welcome back to the Rive. So again, this is Engineer HB. So andito tayo ngayon upang ituloy yung chapter 2, which is the stresses. So we already solved 5 items way back on the video of normal stresses, and ngayon naman magsasagot ulit tayo ng mga past board exam problems para naman sa shear stresses. So samahan niyo ako, halika at simulan na natin to. Okay. So again, don't forget your calculator guys. Sabayan niyo ako mag-solve. What force in kilonewton is required to punch a 20 millimeter diameter hole in a plate that is 25 millimeters thick? The shear strength of the plate is 350 Newton per square millimeter. So kuha muna ako ng yellow tinta. So ang hinahanap is what force in kilonewton. So ang hinahanap is force in kilonewton. So let us F designates the force. So ang hinahanap is in kilonewtons is required to punch a 20 millimeter diameter hole in a plate. So kunyari meron tayo ditong plate. Ayan. Tapos ayan. Ayan. No? To punch a 20 millimeter diameter hole in a plate that is 25 millimeter thick. So ang kapal daw is 25 mm or almost 1 inch. No, kunyari ito yung hole which is a 20 mm, no? 20 mm diameter. So the shear strength of the plate is 350 Newton per square millimeter. So let us designate that by SS kasi nga nasa shear stress tayo na topic, which is 350 Newton per square millimeter or 350 megapascal. So ang tinatanong force, no? So basically, of course, stresses is equal to F over A. Diyan naman ang pinagmulan ng lahat. So palitan lang natin. So this will become an SS for the shear, no? At ang hinahanap is force, which is force over area. So ang area natin dito, so ang area natin dito is yung, syempre, yung pinunch, no? Kunyari meron akong plate dito at pinunch, of course, kung bilog yung yun yung area. Pero since shearing ang pinag-uusapan, hindi normal. So kung normal, it should be the cross-sectional area because it is perpendicular to the surface. Pero kapag sinabing shear, it should be parallel to the surface, no? And your surface is the plate. And the parallel area on that is, of course, the circumference of the circle multiplied by the thickness. So this will be pi dt, no? Kung ito yung pinunch, no? Kunyari ito yung kapal. So this is your diameter, no? So yung parallel surface, dapat yun yung area mo. Kasi ang nangyayari diyan, ang napunit mo diyan is etong area na to, no? Or yung paligid ng bilog. So ano ba yung paligid ng bilog? So that is your circumference. So syempre hinahanap yung area. So ang area niyan is yung thickness. Bakit? Kasi yung bilog, we all know that the circumference kapag nilatag mo ay ganyan, so it is your pi d. So kung rectangular magiging shape nito kapag tiniklop mo yung, or kapag nilatag mo yung bilog, so syempre yung width mo should be your thickness, no? So yan, ang area niyan is pi dt. Okay? So laging isipin, normal is perpendicular to the surface. So kapag may pinunch ka, hinanap ang normal stress. So that was the circular cross-section which has area of pi over 4d squared. Pero pag sinabing shearing or punch, pag sinabing shearing, it should be the parallel to the surface. And the parallel to the surface is your circumference multiplied by the thickness. Okay, so just a little review lang, no? So this is a past board exam problem, and we are all familiar with both normal and shear. So SS is equal to 350 Newton per square millimeter is equal to F, which is the unknown, times divided by pi times diameter of 20 times thickness of 25, and our F should be in Newton kasi mm to and mm, so mm squared. It is cancelled, so matitira Newton. So that was direct sub. 350 times pi times 20 times 25. So that was 549,778.7 Newton. And 1,000 Newton is equal to 1 kilonewton. So just divide your answer to be in kilonewton, kagaya ng sa choices. So ang lalabas is 549. Burin natin. Medyo ayoko ng pangit na sulat. Although medyo pangit na yung sulat ng iba. So this will become 549.78 kilonewton. And we have no decimal on the choices, so it should be rounded up. So that was 550 kilonewton. So meron ba tayong 550 sa answer? The letter A is 450, the B is 550. So ayun. Meron tayong 550 sa B and the answer is letter B. Okay. So next problem. Find the smallest diameter bolt or bolt diameter that can be used in the clevis if P is equal to 400 kilonewton. The working shear stress for the bolt is 300 megapascal. So we are looking for the smallest diameter of bolt, no, for the clevis. So saan ba dyan makikita yung bolt? Of course, ito yon. So this will be our diameter, small d. So this is the clevis, of course. No? So ang hinahanap is the smallest diameter. So walang muna ulit ng yellow na ink. Ayan. So we all know again, it is SS is equal to F over A. No? And meron tayong force which is the P. So pwede natin tawagin itong P over A. So that was 400 kilonewton divided by A. So meron tayong shear stress na 300 megapascal and we are looking for the area. So since this is a shear stress and not a normal stress, dapat lagi nating titingnan ano ba yung napupunit or the parallel surface that is affected by the shear force. So as you can see here, guys, no, ang nadadaanan dyan is pi over 4 d squared. Ibig sabihin, yung nagsasuffer dyan ng stress is yung circular area mo, no? Of course, kapag tinagilid mo yan, kunyari, ito ngayon yung ano mo, yung picture, tapos pag ginanto mo yan, makikita mo dyan itong pin na to. No? Or yung bolt, which is, ang nagsasuffer ng ano dyan, ng shearing stress is itong surface na to. So ano ba yung surface na to? So that was your cross area, no? Which is area of the circle. So that will become pi over 4 d squared. So this will become a direct substitution. So 300 megapascal or 300 newton per mm squared is equal to 400 times 1,000 para maging newton na divided by area, which is pi over 4 d squared. But wait, no, guys, there's more. Why? Because as you can see, dalawang portion ng bolt ang nagsasuffer ng stress na yon. And where is that? So, balik lang tayo sa red ink. So, ang nagsasuffer dyan ay, of course, ito yung isang buong bolt mo, ito, tsaka ito. So, this is not a single shear problem. So, this will be a double shear problem. Ibig sabihin, dalawang area yung nagsasuffer ng shear stress na yan or sumasalo ng force, and it is a double shear area. So, maglalagay ka dyan ng 2. Okay, gets? Gets. Sabihin, makukuha na natin yung diameter. So that was 400 times 1,000 divided by 300 times 0.25 pi times 2. Square root ng answer, and our answer is 29.13 millimeter. So this is the answer. So try mo na hindi double shear. So 400 times 1,000, 0.25 pi times 300, square root of that. So the answer is 41.2. So kapag kinonsider mo siya as a single shear, walang naman sa choices. Siyempre, obviously, you adjust, and matik naman, kita naman sa clevis, dalawa ang sumasalo ng force. So it is considered a double shear problem. So our final answer is 29.13 mm. So ang A is 28.1, ang B is 29.1. So the answer is B again. Okay. Okay, so proceed tayo sa third question, guys. So this is third question. Again, the steel shaft, 3 feet long and 4 inches in diameter carries the end torque of 15 feet. Determine the maximum shear stress in the shaft in KSI. So this is a torsional problem, guys, and we all know that the torsion is under the shear stress. Kung si normal kanina, no, or sa nakaraang video, no, kanina syempre ito yung damit ko parehas. So the normal stress involves the bearing, the tensile and the compressive stress, no? Ano pa ba meron? And the bearing stress and the bending stress. So dito naman sa shearing, it involves the punching, the single and the double shear, no? And syempre, andito rin yung torsional and meron tayong shear stress in beams din. So this is a torsional stress problem. And we all know that the torsion is simply the 16T over pi d cube. Now, originally, nagmula si torsional stress sa formula na T rho over J. And syempre, depende na rin sa J ng or the polar moment of inertia ng material mo. Kung syempre karaniwang ginagamit na shaft is circular. So dito na derive yun basta circular. So that will be 16T over pi d cube. At ang hinahanap is the maximum shear stress. No? So isa-isayin natin. So 16 times torque. So meron ba tayong torque? Of course, it is the 15 feet. 15 feet. So pwede na natin siyang so si feet para maging foot pounds or inches pounds. So 1 kip is 1,000 pounds multiplied by 1 feet times 12 inches. So it will become 12,000 pounds inch. So pwede na natin si 15 ay multiply na natin ng 12,000. Or para hindi ka malito, 15 feet, that will become 15,000 pounds feet. Para maging inches, multiply mo ng 12. So that will become 15,000 times 12. It is basically the same as 15 times 12,000. Divided by pi d cube. So it will become, tanggalin ko na to. So that will become pounds inch. So si diameter is, ayan, meron tayong diameter na 4 inches. So ayan. So inches cube, so this will become cubic inch. So may inches ka sa taas na isa, may cube ka dito, so it will become cubic square inch pala. So that will become pounds per square inch. No? So it should be PSI. So as you can see, ang choices is on megapascal. Pero tingnan muna natin, no? Kasi some of the board exam problem is tama yung figure but the unit is not. No? Pero titingnan muna natin if we convert on megapascal, lalabas ang answer, or if dito pa lang sa PSI is lalabas ng answer. So this is a direct substitution. So it will become 16 times 15 times 12,000 divided by pi divided by 4 cube, and that is 14,323.94 PSI. Okay, so convert natin sa megapascal. We all know that the 14.7 PSI or 1 atmospheric pressure is equal to 101.325 kilopascal or 0.101325 megapascal, because 1 megapascal is equal to 1,000 kilopascal. So just divide it by 1,000 and we're going to get this megapascal. So this become 14.7 PSI times 0.101325 megapascal. So cancel. Ang sagot is, so the answer is 98.73 megapascal, meaning the answer is, the number on the choices is on PSI but the unit is wrong. So ang kaninang sagot natin is 14,323.94. As you can see guys, walang 14,000 dyan. Pero kapag dinivide mo ito into 1,000, it will become 14.32 KSI by, because 1 KSI is equal to 1,000 PSI. And as you can see, ang meron lang na figure na 14.32, sigurahin ko lang ito, gawin ko lang equals, So meron tayong figure na 14.32 sa problem, pero hindi siya na KSI. Pero kaysa naman sa megapascal, wala kang sagot dito na 93 kanina. So 93 megapascal, no? 90, ano ba to? 98.73. So wala ka namang 98.73 dyan. Ibig sabihin, ang answer pala sa choices should be in KSI. So nagkangyayari talaga yan sa mga board exam problem. Pero our answer should be letter A. Kasi 14.32 KSI. So dapat KSI yan. So the answer is letter A. Okay, so proceed tayo sa fourth question. The torque of 100 kip feet produces a maximum shear stress of 8,000 psi in the 16 feet long hollow steel shaft. Note that the inner diameter of the shaft is 2/3 of its outer diameter D. Determine the outer diameter D. So we are looking for the outer diameter D. No, so since this is a torsional, again, a torsional stress problem, obviously, kasi meron siyang torque na given. So we all know that for a solid circular shaft, meron tayong 16T over pi d cube. At kapag sa hollow naman, it is 16T over pi d raised to 4 minus d raised to 4. Okay. So meron tayong given na torque which is 100 kip feet. So pwede natin siyang multiply. Pwede natin siyang multiply. Nabubulol na ako. No? Pwede natin siyang multiply by 12,000 in order to get a torque in inches pounds. So this will become 120,000. Tama ba? Oh, no. 12,000, 120,000. So this will become a 1.2 times 10 raised to the 6 pounds inch or 1.2 million pounds each. So meron tayong torque at meron tayong stress na 8,000 psi or pounds inches squared. But wala tayong small d para mahanap natin yung outer diameter d. Pero meron siyang binigay na ratio which is 2/3 sabi. Note that the inner diameter of the shaft is 2/3 of its outer diameter d. So we may put that SH is equal to 16T d divided by pi times d raised to 4 minus 2/3 d raised to 4. So medyo bloody pag tinype and inaisa-isa. Pero kaya nga ako nandito, I will give you just a little trick that may help us in solving fast the computation. So meron tayo kapag torsional stress, no, or bending stress. So since this is torsional stress, this is a shortcut kapag may relation si inner diameter and the outside diameter. So paano yun? So we may use this formula 16T over pi d cube pero may factor na 1 divided by 1 minus b raised to 4. So ano yung b na yan? So that b is the ratio of your small diameter to the outside diameter. So that is a derived formula. Bakit? Kaysa naman dito, mag-isa-isa ka, kapag nag-shift solve ka sa calculator, mapupuno yung calculator mo. So that may cause you a lag, no, or pagtagal ng shift solve. Pero ito, no, ito kasi parang pinapalabas ng derived formula na to. So this is your solid and this is the factor that make it hollow. Okay, so mamaya isolve ko itong ganito and tingnan nyo na lang sa inyong mga kanya-kanyang scratch na kapag inisa-isa nito ay parehas ang sagot. Pero I will show you pareho yan ang sagot. So your S is 8,000 is equal to 16 times 1.2 times 10 raised to 6 divided by pi d cube since capital D naman ang hinahanap, so there's no problem. So kung small d naman hinahanap, we may first locate or search for this capital D. And syempre may ratio naman siya. Multiply lang natin 2/3 and we're going to have this inner diameter. Pero since outside yung nahanap natin, so it should be, so ano ang B natin? So ang B natin is 2/3 ng outer diameter. So divide by outer diameter. So our B is 2/3. So hindi kita yung fraction. Yeah. So it should be 2/3 raised to 4. Okay, so our D is, no, parehas siyang ma-occupy ng space pero mas mas mabilis masosolve kasi ang hinahanap mo na lang dito is yung D talaga. Okay? So this will become, unahin mo natin yung naka-bracket. 1/1 minus 2/3 raised to 4. So, yan, ganyanin niyo muna guys, yung bracket muna. So, times 16 times 1.2 times 10 raised to 6 divided by pi divided by 8,000. Of course, d cube is equal to answer. So, cube root mo si answer. So, that will give you 9.837 inches. So, 9.837 inches. So, that was 9.84 inches. So, meron ba siyang kamukha sa choices? So, na 8.5, 9.58. So, letter C. Ayun, letter C, 9.85 inches. So, ni-round up na siguro into a 5. No? So, our answer is letter C. Okay, so for the last slide, I will read the question. A cantilever member 40 mm long has a rectangular cross-section of 20 mm by 100 mm and supports a load of 6,000 Newton at the free end. What is the maximum shear stress? So this is a problem of shear stress in beams, no? So guys, ito bibigay ko yung shortcut uli, no? Kaya nga ako nandito, kaya nga derive ito. So in maximum or in a shear stress of beam, so basically or usually meron dalawang given na hugis, which is the circular and the rectangular cross section. So sa circular material na nakakaranas ng shear stress or circular beams na nakakaranas ng shear stress, so the formula is shear stress is equal to 4/3 V over A. So V mo yung force and of course your A is your cross-sectional area. And of course sa rectangle, it is has a shortcut of 3/2 V over A. So ito yan, V. We all know that the neutral axis is somewhere here on the middle, the same as the cross, the same as the circular area. So we have the 4/3 BA and the 3/2 BA. So kapag nakakatanggap tayo ng gandang problem, we may locate first the force and only the area and meron ka ng sagot sa stress. So dito sa taas, ang cantilever, so nabubulol na tayo. Cantilever member 40 mm long has a rectangular cross section of 20 by 100 mm and supports a load of 6,000 Newton. The free end, what is the maximum shear stress? So we all know, no? Sinabi ko kanina dito, since it has a rectangular cross-section, the formula should be 3/2 VA. And that was 3/2 times, ano ba yung V mo? So the force or your shear force is 6,000 Newton. Teka. Divided by area. So this is a rectangular. So this will become a 20 by 100. So ganun lang kadali, guys. So 6,000 divided by 20 divided by 100 times 3 divided 2. So our answer is 4.5 megapascal. So meron ba tayong 4.5 dito? Meron. So that was letter B. Okay, so what is the maximum shear stress naman dito if the member has a circular cross-section of 100 mm diameter given same load of 6,000 Newton? So shortcut formula for the cross-section of circular, which is 4/3 BA. no? So parang nangyari lang guys, dito 3/2, dito naman is 4/3. So that will become 4/3 times B, which is 6,000. And of course, this is longer, not a length times width, but a pi/4D squared kasi nga circular cross-section ng usapan. So that will become 4/3 times 6,000 divided by pi/4 D squared. So that was 100, as is stated here. So this will be a direct sub. So that was 6,000 divided by 0.25 pi times 100 squared times 4/3. So that will become 1.02 megapascal. Or pwede natin sabing 1 megapascal na lang. Kasi walang decimal sa mga given or sa choices. So meron ba tayong 1 dito? Ayun, letter A agad is 1. So malayo siya sa 2, sa 3, and 4. Of course, the nearest answer is 1 megapascal. And our answer here is letter A. Whew, ayun. Okay, so naka 6 items tayo for the shear stress. And guys, I hope nakatulong ako sa inyo and I hope natuto kayo sa akin. So I will continue to upload board exam or past board exam problems for the machine design. So meron tayong bukod na videos for the mathematics, sa power plant, and syempre some derivations formulas. So, kaya nga binuo ko tong derive, So salamat sa pakikinig guys. Kita-kita tayo sa mga next videos natin, and ayun, follow lang tayo sa page and subscribe to my channel. So wag mahiya magtanong. So pwede niyo po akong PM directly. So kita-kita tayo sa susunod na video guys. Salamat sa pakikinig ulit, and good luck sa inyong review. God bless and bye-bye.